Okay, I guess we can start now as we have 11 people. So yeah.
Hello.
Hello, hey Jason. Um, so today our topic it's gonna be about astrophysics, which is like astronomy and physics combined together, I guess you could say. And and yeah. So if you guys want could you guys like open your cameras if that's fine with you guys? I know some of you guys might have broken cameras, which is fine, but it's just best if you can. That'd be great. Okay. So, um, so yeah, today we're gonna be talking about an introduction to astrophysics. This is like the basics. You don't really need to know any background information really, but yeah, let's get started. Okay, so what we're gonna be going through today is what is astrophysics? So like the introduction of astrophysics, what is like it the study of, how it started. So this is like how the universe was created. And then this, we're going to be talking about the Big Bang Theory. Some of you guys may have heard of the Big Bang Theory. And then we're going to have what is everything made of? So what is the universe made of? What are like the three main things that the universe is made of? And we have what is the largest known object in the universe, and then I'd be talking about similar things to the largest known object in the universe. And maybe if we have time, I can get a short video in, and yeah, and that'd be it. So, okay, so the first section we have what is astrophysics. Basically astrophysics, it's the study of the universe. So it's to like explore things that are beyond our earth, and to like search learn new things about stars, about black holes, about like the creation of the universe. And astrophysics is also part of finding terrestrial life. So if you don't know what extraterrestrial life, it's basically aliens. It's life that isn't from Earth. And during the night, when we look up into the sky, we could see, like, especially with lights, all the lights turned off, you could see all those skies in the sky. And the majority of those are part of our galaxy. So those stars are part of our galaxy. And in each galaxy, there are a few billion stars. And then in each galaxy group, there's like around a few like 50 galaxies, or 5 to 50 galaxies. And then in each galaxy cluster, there's 5 to 50 galaxy groups. And then there are a few billion, or I believe a few billion galaxy clusters, which make up the universe. So approximately in the universe, there's 200 billion galaxies. And if we times that by a few billion stars, that'd be like almost 2 trillion stars. And but there's probably gonna be more, as this is like what we have discovered so far. Okay, so in this picture you could see like all those stars, and most of those stars are part of our galaxies, our galaxy. And so the brighter stars in those pictures, it can mean two things. The star is very bright, or the star is very close to us. So if the star is very bright, that means its light around the star is very large. So it can be seen from a further place than a star which is very dim, where it doesn't produce a lot of light. And because a star is closer to us, that means there's going to be more light towards us. So this is why like planets in our solar system, they also sometimes shine. And this is why the sun is always so big and bright. So usually if a star is closer to us, that means it's bigger and brighter. Okay. So next up, we're gonna be like talking about the search to find others. So this is like finding extraterrestrial life in our galaxy currently, and then we're gonna slowly move on into bigger areas. So astrophysics is also the search to find others in the universe. So we're trying to find aliens and extraterrestrial life. And a big question in astrophysics, and if you like watch any shows about that like interviews astrophysicists, a lot of the questions or some of the questions, there's gonna be, are we alone? So like, are we alone in this universe? Is there like other living species in this universe? And so this is like a huge like thing in astrophysics, and it's something that's like very important. There's also debates about if we're alone or not. And so currently, right now, the possibilities of having other living species is a very high possibility. And the more stars and the more planets we discover, that means the higher the possibility or the percentage becomes that there's going to be extraterrestrial life on that planet or in that star. So, so currently, most astrophysicists believe that there's life out there, and it's sort of what like most people I'd say believes too, but it's still not guaranteed yet, as we still haven't found any extraterrestrial life outside of Earth. And then there's also in 2012 Voyager 1, which is it's like, I guess you could say a satellite or like a rocket ship, but a satellite orbits around something. I guess you could say like a messenger. And basically Voyager 1, it carries like the voices of presidents and prime ministers and other important leaders in during 2012. And now it's technically out of the solar system. So it's past like it's past Pluto. But it's still not out of the solar system because we have another asteroid belt around the solar system, and according to scientists, it's gonna take a few maybe 1,000 years for that messenger to, or Voyager 1, to actually leave the solar system, so like go past the asteroid belt. And I guess searching for like others and it's like very important, but there's also debates about how maybe we shouldn't search for these aliens, as if we find them, they're probably going to be more advanced than us, so they can like do more damage and harm to us. So then we can do damage to harm, as we're not that developed yet, as we're not like a more planetary species. But another argument for the other side, it's basically why we should go find aliens, is because, well, it's good to know if we're alone or not. And it's also because not all aliens could have like empathy. So empathy is basically where they have respect, and they have kindness towards other species. So they could have empathy, they could help us, they could learn stuff from us, and we could learn stuff from them. And this is like very important. It's similar to how I'd say let's say the Europeans, they found North America, and or they found America, where they like studied hunting, they had trades, and stuff like this could also be built through if we find extraterrestrial life. But if we also look at the perspective where us underdeveloped than them, we could like become their slaves and stuff, which is pretty bad. and we don't want that to happen. So so we should like be more developed before we actually go out and search for aliens. Okay, next slide. So how did it start? So how did it start? It's like the Big Bang Theory. It talks about the Big Bang Theory and how the universe was created. And in the picture here, we could see like the Milky Way, which is our galaxy. So these are all the stars in our galaxy. Okay. So if you guys have any questions so far, just raise your hand up or type it in chat. I'll try my best to look at it. And you guys could also unmute. So because I know this part, it might get a bit confusing maybe. So if you guys have any questions, you could just ask it. So the first 1 million years after the Big Bang. So before the Big Bang, everything was put into a single dot. So all of the universe we see today was, imagine it was in a single dot. And because it's so much things, there's so much things in that one dot, it expanded. It needed more space to fit everything. So it expanded. And the particles and everything in the dot started to like expand. And it was expanding approximately 1 trillion times its size, its normal size. So imagine a dot 1 trillion times in 1 second. And then that became 1 trillion times. So within a minute, it was around the size of our solar system. So that dot within a minute became the size of our solar system. And if we get to, if we have enough time, the video will explain this furthermore. So, in less than a second, there were things created called quarks. Quarks and other quarks, they were created, and then they'd smash directly into each other, and then they would disappear, which caused more quarks to be created, and they smashed and repeated. And because everything was fit into a very small dot, the temperature inside the dot was very hot. So I believe it was over 1 billion times hotter than the sun, which is like very hot. And because of the heat, that means the quarks would move around a lot. So like, let's say if we have hot air, that means the air molecules are like moving around very fast. So it was the same thing for quarks. So they'd smash into each other and then disappear, smash into each other and disappear. But then once the temperature started to decrease as it expanded, there's more area. So like the it didn't have to, they didn't have to like move around too fast. Then the quarks became more stable. So they became like firm. They wouldn't crash into each other again. And once the temperature continued to decrease, by now it was like almost, I believe, 500 million times the heat of the sun. So it was still a lot. It formed into clusters, which created like hydrogen atoms and different other atoms. And this is how like the elements were created. And once there was atoms, it formed together to create like the first stars and then the galaxies and etc. So so that was roughly around what happened in 1 million years. And I believe by the end of the 1 million years, all the galaxies were formed. So like we technically can't form any other galaxies because the galaxy, before they used to have like a large star in the center, and then planets would revolve or orbit around the star. And then once the star collapsed, it became a black hole. And this is why like all galaxies, they have a black hole in their center. And as planets continue to orbit around the black hole, and these black holes are very large. They some of them I believe could reach up to 3 times, like inside the point of no return, or like the horizon line. You could fit 3 of our solar systems in there. And so in the first million years, the temperatures started to decrease as particles slowly formed. And then now I'm going to talk about like the universe now. So how's our universe like right now? And also if you guys, oh, sorry, I forgot to mention this previously, but the reason why the dot continues to expand for a long time is because of dark energy and dark matter. I'll get to that later in today's class. So the universe is expanding faster than the speed of light. So what this basically means is some stars are like out there, but we can't see them, and we can't travel there because due to Einstein's theory, nothing can be faster than the speed of light. So we can't travel faster than the speed of light. And if the dark energy is the counter of gravity, it's like the opposite of gravity. It pushes things away from each other. And the further, let's say we have 2 objects and they're like gravity is pulling them together, and then dark energy slowly pushes them away. The further it is, the less gravitational force they have between the objects. So it's the easier it is to push away. So maybe at the start, it goes slowly, it slowly pulls apart, and then it starts to get faster and faster and faster. So this is why some parts of the universe we can't explore anymore, as it's too far away. It's moving away faster than the speed of light due to dark energy. And currently the temperature is still dropping, and in space it's very cold. So I believe it's I forgot what degree it was, but it is very cold in space. And so if you if you don't wear your spacesuit in space, you're gonna freeze to death like very soon. And no more galaxies can be formed because all those big giant stars that were formed, they can't be formed anymore. As usually if we have a huge mass of these hydrogen gases around, that means they're gonna form into smaller stars, as the temperature in space doesn't allow them to form into those, we call them primordial stars, which are like very large stars. And so I previously mentioned black holes are the center of each galaxy. And we are in the Milky Way galaxy, and we orbit around a black hole too. And so a reason that Earth is traveling at, I believe, 10,000 kilometers an hour. And the reason we can't feel that is because the Earth is so big and we're so small. So let's say we are in a car. We are in a car and it's driving very fast. It's because it's going very fast and the car isn't that big, we can slightly feel the movement. But because the Earth is so big, its movement, we don't feel the movement. And it's the same thing on why our galaxy is rotating around the black hole, and it's traveling at a few million miles per hour. And this is why like we don't feel that we're like spinning around or anything. Okay. By the way, again, if you guys have any questions, please ask me. It'd be great if I could help. Okay, so now we're gonna talk about the Big Bang Theory. So what is the Big Bang Theory, and what do we know about the Big Bang Theory? The Big Bang Theory is basically what I previously mentioned, when everything was squeezed into a dot. And by the way, a dot is 0D. So there's 1D, which is a line, and then there's 2Ds, which is like the Cartesian plane where you can have diagonals and other things. And there's 3D, which is like a cube. But 0D is just a dot. There isn't any length to it. And it like the dot expanded. Oh, sorry, this should be within a minute after the Big Bang, the universe was the same size of our solar system. Basically there was like a sort of a proof of why the Big Bang was created, as because there was we discovered radiation from stars, which allows us to go back in time to see like sort of what happens. So it was known. So there's like graph. I don't have it on the slide, but I can show you. So it's something like this. So if we see in this graph, you guys can see like there's a point here. Sorry.
Yeah, it says a timeline. It looked like a timeline. Is it a timeline?
Yeah, it's sort of a timeline, but like this is 13.7 billion years. So it's like a very long time. And at the most left, you could see like it like very quickly expanded. And yeah, so within a few million years, there were like stars, and during the dark age is basically when like the quarks and stuff interacted with each other. And then yeah, okay, I'm gonna wait. Okay, stop share, and then okay. Can you guys still see my screen right now? Okay. So this is like the Big Bang Theory. And due to like the star radiations that it gives off, this is how like we sort of found out about the Big Bang Theory. But this could be not true though. This is what most astrophysicists think about how it started. But how there was a dot in nothingness, that is still unknown. And so what we don't know about the big or about space and stuff is that this theory is technically made up. We can't really be guaranteed this theory is true. There are other theories about how the universe is created, but this one, to most astrophysicists, it seems like it's the most logical. So it's like the one that makes the most sense to most astrophysicists, as it sort of has evidence. And some of the specific details aren't accurate. So scientists aren't sure if it was exactly like which time period, but they're sort of, they know what they're talking about. And there was like, there's still details that are missing from what science, or like details that are missing about the Big Bang Theory that scientists are trying to figure out. Okay. So now we have part 3, which is what is everything made of? So what are we made of? We are in a category, what our desk, what space, and what the universe is made of. Okay, so in space, there are 3 categories that make up everything. There's dark energy, there's dark matter, and then there's atoms. So dark energy at the bottom, if you guys could see, it says this is approximately 71.4% of the universe. So this is a large number. And then we have dark matter, which is 24% of the universe. And then there's atoms, which makes up 4.6. of the universe?
I don't even know one of those things.
Yeah, okay, it's fine. I can explain it to you later. So, okay, I'm gonna start off with the atoms, as you guys probably know. It's like maybe the most common term that you guys know. So atoms are us. It's humans, planets, stars, your table, your computer, your iPad. These are all made out of atoms. And our Earth is so big, and there are so many more planets and stars out there, and that's only 4.6% of the universe. And that's very little compared to dark energy and dark matter. So we can see by this how big our universe is, as all these stars combined is only 4% of it. Next up, we have dark energy and dark matter. So I'm gonna start off with dark energy, as I guess because I previously mentioned it a bit. So dark energy is a theoretical repulsive force that pushes objects away from each other. So this is why the universe is still currently expanding. And so this is pushing each planets and stars away from each other. But the only reason why galaxy groups, they hold together, is because of gravity. The gravity is strong enough to keep these galaxies together. But each galaxy groups are slowly separating apart because of dark energy. And then we have dark matter, and dark matter is a theory that it is a material that is due to belief. Dark matter is a theory that is a material and that is created due to belief, and it could take multiple forms. Sorry, there was a bit grammar mistakes in there. But basically, dark matter, it's in each cubic centimeter. So let's have a cube that is a centimeter wide in height, width, and length. There's around 100 trillion dark matter particles in that cube. So that's a lot too. And this takes up approximately 24% of the universe. Both dark energy and dark matter are theoretical, so there isn't a lot of things that we know about dark energy and dark matter. And these could be completely made up. But this is why this is what scientists believes are explaining these like phenomenons. These are why the universe expanding, why so these are the explanation. And I'm gonna go over the form of an atom. So I'm gonna show you guys a picture of an atom. And okay. Here, and then I have to share my screen again. Oops. Okay. Here. So this is like sort of the structure of most atoms. There are electrons, and there are neutrons, and there's protons. So what this the neutron is and protons are like the center. So they're the nucleus, and the electrons, they like swirl around the nucleus very fast. I believe it's almost 10 billion times each second. So around the nucleus. So that's very fast. And these are what holds up everything. So let's say if there were no atoms, we wouldn't exist. Or if there were no atoms, then the planet, so planet Earth, would become liquid, and everything around us, including us, would become liquid. There isn't a structure to the object. And so atoms are everywhere. So
Oh, you mean the atom, like the small little things that we can't see?
yeah. Those
Oh.
yeah. It's not like a space term. It's just a normal atom. And atoms could be very destructive. If you guys know about the atomic bombs, that's basically when you try to separate an atom apart from each other, it creates a huge bomb. And then there's hydrogen, which is you separating the hydrogen atom from each other, which creates a bigger bomb. And this could be very destructive. And it's hopefully not to be used again by us humans, as it is very destructive. I believe the current times, with the amount of bombs, like these nuclear weapons that we have, we can kill the Earth, so kill everything around the Earth 117 times. So we can basically bomb the Earth 117 times, killing everything 117 times, with all the nuclear weapons we have right now. So yeah, so atoms are guaranteed that we know it's true, and dark energy and dark matter are things that are theoretical, so we're not sure. Okay, is there any questions so far? You could raise your hand up if you have anything. Anyone? Okay, next up. So what is the largest thing in the universe?
The galaxy.
Okay, here, how about I put it this way? What is the largest single object in the universe? Any guesses?
Air.
Air is very small.
Let's see. It's definitely what was stars, planets? I don't know. Star is it
matter?
Pardon?
Dark matter.
Okay, dark matter is very small too. It's just there's a lot of dark matter. No, it's not a star. It's not a planet. It's not the universe, because.
But let me think.
Huh?
Let me think.
It's close to a star though. After
Starbucks?
Pardon? Leon? Did you?
Nothing.
That's us. Explosion.
No.
Galaxy cluster.
No. Okay, a galaxy. Okay, here, I see in the chat there's the universe. That
Galaxy
technically
clusters.
doesn't. No, it's not galaxy clusters. Timothy,
A quark.
a quark? No, the quark is very small too. Okay, so currently in the universe, galaxy, galaxy cluster, galaxy groups, they all don't count, as they're like multiple things in to create one big thing. So that doesn't count as a single object. Okay, any last guesses? Anyone?
Solar systems.
No, that's
Largest thing is the
Pardon?
largest thing.
What
the
do you mean?
largest single
Largest
object
thing.
in the universe.
Yeah. Oh yeah. The largest thing is the largest thing.
No, it's not.
Why is two
but-
Jasons?
Nice try. Okay, I'm gonna. Yes, Eric got it right. It's a black hole.
What?
Wait, no, black hole isn't the biggest thing.
But remember, there are a lot of black holes, and some could be like very small. Some could be like the size of a penny.
Isn't black hole made of stars? If a star explode, a black hole would appear?
Okay, if a big star, it collapses itself. So inside each star there is a core,
Yeah,
and
like the sun.
if the core becomes mainly iron, the star is gonna collapse itself. So the core is made out of different materials, different elements, and if it becomes mainly iron, it's gonna collapse into itself. And let's say it's a very big star. It's there's a possibility it becomes a neutron star or a black hole. And okay, so I know this picture isn't the highest graphic quality. It's like a cartoon thingy, but
Oh,
this is
isn't it Han 618?
yeah, it's a black hole.
I read this book before. I read it at the library once.
Oh, nice.
Oh, this picture is photoshopped from this YouTuber I think I watched.
Yeah, it's
No, this
Kyrgyzstan.
It's a black hole.
Yeah.
I'm not sure how. Yeah. So basically, in that video, it talks about black holes, and yeah, I like those videos too. Or I used to like them, and I watched so many of those videos. So this is ton 600 and
Milky Way combined.
yes. So because black holes, they are so like dense, their mass is very large. So this single black hole, it's worth 66 billion solar mass. So
Also, if you got stuck in there, you would never return back. It would be like a few trillion years or something.
yeah, well, like most black holes, if you get stuck in black holes, you can never escape. But it has like, if you look around it, it has stars and tons and thousands and millions of stars with planets orbiting around it. I believe this the second largest black hole, it has another smaller black hole orbiting around it.
Wait,
And
what?
yeah, and this one is 4 times that size.
But don't start. Doesn't black hole disappear sometimes?
It does, but it takes a very long time. I'll tell you guys. Okay, I'll explain this now. So there are particles in the universe where they like come together and they like form into one thing. But let's say we're in a black hole. So this is like, how do I? Let's say I have an imaginary black hole right here. It's a circle, and at the edge of the black hole, there are these two particles. Usually outside, these two particles merge, but inside the black hole, it move outwards. So because of this process, black holes are getting smaller and smaller, but black holes at the same time are getting bigger and bigger as they're consuming stars and planets. That it's like if you eat a lot of things, you get very fat. Yeah.
Yeah. So you mean if it grows bigger, we can actually see it from Earth? Can we actually see it from Earth? Because you said it's big boy.
Okay, so this is.
I know it weighs like it's like 60 something billion thingy.
Yeah. So we can't see it with our eyes. So basically this picture, or like what we know, it's 66 billion solar mass, is from 10 billion years ago. Because light, it travels at a certain speed. And because the universe is so large, it takes light 10 billion years from Earth to travel to this black hole. So currently it's probably even bigger than what it is.
Wait, so you're saying time travel in a different way?
Not really. It's just that a light has a speed. So when we look at something, so let's say I'm looking at my screen. if I close my eyes, that means I can't see anything. But once I open my eyes, a light from my eyes, or light from the screen, I should say, comes to my eyes at a speed. And light is very fast. It's I forgot the number here.
It's very, 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 very fast. The time,
just
time
put
of
it this
light
way, it's
is
very, 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 very fast. It orbits, it can go like circle the Earth 7 times in a second. And it takes 10 billion years for light to travel to this black hole. So it's a very far part. So what we're looking at, so the 66 billion solar mass, is from 10 billion years ago. So during this time, the black hole probably is going to be larger than it is.
But will it be smaller? When will it disappear?
Okay, so currently, the last thing in the universe is going to be a black hole. So once everything else in the universe dies, the only remaining thing is going to be a black hole.
Then where do our generation live? If just everything's just black hole.
We don't live. Like there isn't going to be any stars, any planets left for us to live on. So this is why, but this time is going to be
why can't we just live in space?
Pardon?
Why can't we just live in the black hole or space?
Because black holes, okay, first of all, we don't know what's going inside a black hole. We don't know what's inside a black hole, and so we don't know if it's inhabitable or not. And second of all, once we enter a black hole, there is no escaping. Even light can't escape from black holes. So this is why around a black hole, it's pure black, and the only sometimes you could see a black hole is because there's light around it. So here at the middle, there's a black hole, and then there's light around it. That's light like moving around a black hole or orbiting around the black hole. So that's how strong a black hole is in. And basically a light black holes are going to be the only living thing. You don't have to worry about this because you're going to die in a few, maybe 100 years. But the black holes, the last black hole is going to die. You guys know the number Googleplex?
Duh.
Yeah, it's going to die after that many years.
But then, okay.
So by then, Earth, humans,
everything will be extinct. Yeah,
everything would be extinct, and that would be when the last black hole would die. So that would be where everything becomes nothing again. You know?
Or if our technology is better, we can actually live on space.
So technically our technology right now, we can go.
I mean, like the future.
Yeah, in the future, yes, we could colonize other galaxies or other parts of our galaxies, and yeah, this is a big dream for humans. But first of all, there are a few problems that we have to solve our problems on Earth, as this is going to be a long future. And climate change, it's going to be coming in the close future, so we have to focus on these things too. But also we can technically colonize Mars right now. So we have the ability to colonize Mars and Venus, in fact.
Yeah.
It's just that in order to colonize these planets, it's going to take 1,000 years or more than 1,000 years. So this is a generational project.
No.
It's going to take a long time for us to inhabit. So this is why we haven't started, or I guess you could say Elon Musk, he has already started to plan to colonize Mars.
SpaceX.
Yeah, SpaceX. But yeah, so this is but it's still gonna take a long time. Okay, what was I talking about? Oh yeah, black holes. Um, Mars, they have ice. So
Yeah,
they have
waters.
ice, so technically they have water. Uh, but so currently there's like something going on. It's in the North Pole or South Pole, I forgot which one. They have discovered ice, but if there is water under the ice there, that means there's a possibility for there to be living things. Us humans, we a few billion years ago, we came from bacteria, which grew on through in water.
Wait,
So
so we're wait, what? So we're actually bacteria?
I
I found they're like
bacteria
atoms.
evolved. So the first things in living species were algae, which created bacteria, which later on evolved into us and mammals and dinosaurs, and then the dinosaurs got killed, so the mammals could evolve, and then the mammals evolved into us.
Okay. Okay.
Okay. So and wait, well, sorry, I lost my train of thought. Oh yeah, so this black hole is really big, and black holes, something weird about black holes is they could defy physics. They could make physics like just go away. They also don't follow time. So basically, when you get closer and closer to a black hole, let's say you're like 2 kilometers away from the event horizon of the black hole, time is going to be slow, speed up for you as a perspective. So you see like galaxies have birth and die, and other not galaxies, stars create stars, and stars die, and time as time goes faster. But for the outside world, it seems you're very slow. So, but for you, it seems you're like going very fast. Everything around you is very fast, and outside people, let's say if I'm looking at you a few thousand kilometers away, you'd be like moving very, very slowly. And so this is something special about black holes. It sort of stops time, sort of makes time very, very look like it's very slow, or like it bends time. And it also bends physics, as there's like I'm not sure exactly how it works, but apparently black holes, they don't follow the laws of the universe. So yeah, which is kind of cool but weird at the same time. And black holes, they have a huge mass. So a black hole the size of like cent could be as heavy as a city. So like let's say there's a black hole maybe this big. Its mass is around, maybe we could say, Toronto. Like not GTA, but like Toronto, if those of you guys who live in Toronto. Yeah. So the mass of a black hole is very large. And the bigger the black hole gets, so I believe a black hole the size of a city has the same mass as a black hole, as our sun. And then it gets larger and larger. So TON 618, through its event horizon is like basically where you can't go back even if you travel at the speed of light. If there's like, if the event through the event horizon, you can fit 11 of our solar systems at this diameter. 11 solar systems. And this is like the full solar system. This includes the asteroid belts. And it takes light a week to travel from the event horizon to the center of the black hole. And then it takes another week for light to travel from the center of the black hole and then out. So it takes 2 weeks for light to go past the whole black hole. Okay, and then next up, finally, we're gonna have a short video about the Big Bang Theory. Sorry, it's an ad right now.
The beginning of
Can you guys hear
everything,
this?
the Big Bang,
Can you guys hear this?
the idea,
Okay.
the beginning of everything, the Big Bang. The idea that the universe was suddenly born and is not infinite. Up to the middle of the 20th century, most scientists thought of the universe as infinite and ageless. Until Einstein's theory of relativity gave us a better understanding of gravity, and Edwin Hubble discovered that galaxies are moving apart from one another in a way that fits previous predictions. In 1964, by accident, cosmic background radiation was discovered, a relic of the early universe, which together with other observational evidence made the Big Bang the accepted theory in science. Since then, improved technology like the Hubble telescope has given us a pretty good picture of the Big Bang and the structure of the cosmos. Recent observations even seem to suggest that the expansion of the universe is accelerating. But how did this Big Bang work? How can something come from nothing? Let's explore what we know. We can ignore the beginning part for now. First of all, the Big Bang was not an explosion. It was all space, stretching everywhere, all at once.
So by the way, it says 10 to the power of -35. So this is 1 over 1 and then 35 zeros of a second. So this is what happened in that of a second.
The universe started very, very, very small and quickly expanded to the size of a football. The universe didn't expand into anything, space was just expanding into itself. The universe cannot expand into anything because the universe has no borders. There is by definition no outside the universe. The universe is all there is. In this hot, dense environment, energy manifested itself in particles that existed only for the tiniest glimpses of time. From gluons, pairs of quarks were created, which destroyed one another, perhaps after giving off more gluons. These found other short-lived quarks to interact with, forming new quark pairs and gluons again. Matter and energy were not just theoretically equivalent, it was so hot they were practically the same stuff. Somewhere around this time, matter won over antimatter. Today, we're left with almost all matter and nearly no antimatter at all. Somehow, 1,000,000,001 matter particles were formed for every 1 billion particles of antimatter. Instead of one massive ultimate force in the universe, there were now several refined versions of it acting under different rules. By now, the universe has stretched to 1 billion kilometers in diameter, which leads to a decrease in temperature. The cycle of quarks being born and converted back to energy suddenly stops. From now on, we work with what we have. Quarks begin forming new particles, hadrons, like protons and neutrons. There are many, many combinations of quarks that can form all sorts of hadrons, but only very few are reasonably stable for any length of time. Please take a moment to appreciate that by now, only 1 second has passed since the beginning of everything. The universe, which has grown to 100 billion kilometers, is now cold enough to allow most of the neutrons to decay into protons and form the first atom, hydrogen. Imagine the universe at this point as an extremely hot soup, 10 billion degrees Celsius, filled with countless particles and energy. over the next few minutes, things cooled and settled down very fast. Atoms formed out of hadrons and electrons, making for a stable and electrically neutral environment. Some call this period the Dark Age because there were no stars and the hydrogen gas didn't allow visible light to move around. But what's the meaning of visible light anyway, when there's nothing alive yet that could have eyes? When the hydrogen gas clumped together after millions of years and gravity put it under great pressure, stars and galaxies began to form. Their radiation dissolved the stable hydrogen gas into a plasma that still permeates the universe today and allows visible light to pass. Finally, there was light. Okay, but what about the part we didn't talk about? What happened right at the beginning? This part can be defined as the Big Bang. We don't know at all what happened here. At this point, our tools break down. Natural laws stop making sense. Time itself becomes wibbly-wobbly. To understand what happened here, we need a theory that unifies Einstein's relativity and quantum mechanics, something countless scientists are working on right now. But this leaves us with lots of unanswered questions. Were there universes before our own? Is this the first and only universe? What started the Big Bang, or did it just occur naturally based on laws we don't understand yet? We don't know, and maybe we never will. But what we do know is that the universe as we know it started here and gave birth to particles, galaxies, stars, the Earth, and you. Since we ourselves are made of dead stars, we are not separate from the universe. We are part of it. You could even say that we are the universe's way of experiencing itself. So let's keep on experiencing it until there are no more questions to ask.
Okay, that was sort of like explaining the Big Bang Theory. And one last thing before we go. So you know how I mentioned how once the last black hole dies, there's going to be nothing left. So this is why just now, closer to the end of the video, it was like the big bounce. It's like a universe dies as it becomes nothing, which is like when the last black hole dies. And then it suddenly explodes again. So another universe is created. So this could be another theory that scientists are working for. Okay, this is going to be the end of our class today. It's 8 o'clock, so bye everyone. Bye.
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 Bye. Bye, guys. Bye, Eric. Yeah.